Hello everyone. So for this video, we're going to be going over what I call homework section 3. For you guys, I believe it's actually section 4, but some of you guys are still taking section 3 and that's okay. So I went ahead and went on to the next section because it looked like pretty much everyone completed it. So these questions cover substitutions, which is one of my favorite sections. Super excited. And these are problems on the AP Calculus AB exam. You'll notice there aren't as many questions in this video, and that's because for the most part, you all did exceptionally well. I had a lot of 5s and a lot of 4s in this section, and there were some questions that no one got wrong, so I didn't include those in the video, and I tried to just focus on the problems that we really struggled with. So let's go ahead and get started. The first question says, if the substitution square root of x equals sine y is made into this integrand, the resulting integral will be. So there said, we're going to let the square root of x equal sine of y. And so if we take the derivative of both sides, we'll get that dx times 1 over 2 square roots of x equals dy times cosine of y. So then when we solve for dx, we can say that it equals dy times cosine y times 2 square roots of x. And again, the square root of x equals sine y. So we could even write this. Oh, let's go back. I don't know why it clicked. We could even write this as dy times cosine y times 2 sine y. Okay, so we have, and I'll do this in a different color, we have the integral, 1/2, so much for a different color. Let's see. So we have the integral 0 to 1/2, and note this is when x equals 0 and x equals 1/2. So when you do substitution, you also need to change the limits. And we have the square root of x over 1. I'm going to write x as the square root of x squared dx. So that this equals, and so our limits will change. If x equals 0, well, I'll just go ahead and leave it like this. I don't want to solve that just yet. So we'll put when x equals 0, x equals 1/2, we get sine of y in the numerator over the square root of 1 minus sine squared of y times, we have to change dx into terms of dy. So we're going to change that to dy times the cosine of y times 2 sine y. Okay, I can pull that 2 out. We have x equals 0, and then x equals 1/2. So I can pull the 2 out, and I can combine the sine terms. So I have sine squared of y times cosine of y dy. And notice I have 1 minus sine squared. So remember, let's go back. Remember that cosine squared, and we'll say x, plus sine squared of x equals 1. So that cosine squared of x equals 1 minus sine squared of x. So I can plug that in here, and we get cosine squared x under the square root. We have 2 when x equals 1/2, when x equals 0, and we'll get sine squared of y times cosine of y over cosine of y, and all in relation to y. And so we see that these cosine y's will cancel out. And so now I want to change the limits of integration because I believe that's what they do in the problem. And so we decided to let the square root of x equal sine y. To make this easier, I'm going to say let x equal sine squared of y, just because I don't want to have to solve for x and y. So that when x equals 0, right, I want to know what is y that I get that. And so I'm going to draw, well, let me write the other way, and then I'll draw my unit circle. And then when x equals 1/2, what is y? Okay, so another color, I'm going to draw the unit circle, which you need to have memorized. And so at this point, right, we see that y is going to be 0. So we have 0, 1. Oops, did not mean to erase that line. We have 1, 0. We have -1, 0. I just realized I definitely wrote these. This is 1, 0. This is 0, negative. Oops, 1, and this is 0, -1. And then note that this is square root of 2 over 2 at 45 degrees, or pi over 4. So I know that I'm going to get 1/2 when sine is pi over 4. And the other question is, when am I going to get 0? So it's kind of confusing because here we've used y instead of x, but note that we're kind of saying when is the sine of x? And sine is actually the y value. So we're asking is when is the y, right? Because we think of cosine corresponding to the x value and sine corresponding to our y value. So when is that y value going to give me 0? And my y value is 0 at 0 and at pi. And, of course, every rotation thereof. So now my limits are going to change to 2, right? We're going to keep the 0. And x equals 1/2 at pi over 4. So which answer choice will that be? And of course, this is the integral sine squared of y dy. Okay, and so here we see we have 2, 0 to pi 4 sine squared y dy. So some common mistakes, right? If you didn't have that 2, if you didn't change, so these in A and B, they didn't change the limits of integration. And this one, it looks like you changed limits of integration, you just didn't change it correctly. So we really want to be careful that we know our unit circle. Okay, next question. Using the u substitution, u equals 2x plus 1, this is equivalent to what statement? So they decided to let u equal 2x plus 1. And so we're going to change our limits. So to do that, I want to put this in terms of x. So that I say u minus 1 equals 2x, right? And then u minus 1 over 2 equals x. So that when x is 0, oops, I didn't mean to put it that way. That's okay. Anyways, so when x is 0, u equals 2 times 0 plus 1. We get 1. And when x is 2, I'll put u2 is equal to 2 times 2 plus 1. So our limits will change to 1 and 5. And then also, this will change to u. And then finally, du is going to equal 2 dx. So that dx equals du over 2. And so we'll solve this in a different color. And I'll say the integral from 0 to 2 for 2x plus 1 dx is equal to now the integral of 1 to 5 for u times du over 2. Okay, so, and just kind of like going back, we see we have the 1/2 pulled out and the 5/1 for limits of integration. So I'm looking for a 1/2 that eliminates d and e, and I'm looking for limits of integration of 5 and 1. That eliminates A and B. And so we're left with answer choice C. So it looks like the biggest problem we had was we didn't change the limits of integration in this problem. Okay, this one most people got right, but we're going to go ahead and review because here they don't tell you what the U substitution is going to be. You want it to be the biggest value, right? Because I see the derivative of x to the third in the problem. So I'm going to let U equal x to the third. So that du equals 3x squared dx, and then dx will equal du divided by 3x squared. So when I put the substitution in for x squared cosine of x to the third d to the x, now I see that I have x squared times cosine of u times du divided by 3x squared. So that these will cancel out. And I should have left the integral symbol. Okay, so, I'm going to go back so that we get the integral of 1/3 cosine u du. And then you can plug back in after you take the integral because this is an indefinite integral. And so we get 1/3 sine u equals x to the third plus c. And most of us, we got this correct. Just a couple of us. It looks like, I'm not quite sure what we did. Maybe we did our substitution a little bit differently. Okay. So this question we've done a number of times in our homework. I think we got confused on our integral and derivatives. So this is telling you if dy dx equals tangent of x, then what is y? It's asking you to find the integral of tangent x dx. And I'll say that this is kind of confusing. Again, this is why we've done this example problem and how you go from the answer to this answer. And so let's go through that. So, on this problem, we say this is equal to the integral of sine x times cosine x. And then we have dx. Here, I'm going to let u equal cosine of x. Let me find my mouse. Okay, so I'm going to let u equal cosine of x so that du equals the negative sine of x dx, and that dx equals du divided by negative sine of x. So I did this because now my sine of x's will cancel out. So this turns into the integral. This turns into the integral of sine x over u, because u equals cosine x, times negative du over sine of x. So the sines of x cancel out and we're just left with u. So you get negative natural log of u plus c, where u equals cosine of x plus c. And this is kind of where it gets tricky, because then we could say this is the natural log of the cosine inverse of x plus c, and that's equal to the natural log of the secant x plus c. So for this problem, I highly recommend you just get familiar with the integral of tangent x, because this is something that now we've done 4 different times. You'll probably see a question like this on the AP exam, and it's not really difficult. It just requires you to remember your algebra. Okay. This next question says, using the substitution u equals the square root of x, the integral of this function is equal to which of the following? Okay, so if we, oops, we're not done. We're going to go back. Oh no. We'll just do it right here. Okay, so if we let u, oh no, I have a galaxy. Let's change that. Let u equal the square root of x. Note that the derivative of this will be 1 over 2 square roots of x dx. So that dx turns into du times 2 square roots of x. So that when I solve this, and again, we have to change our limits from 4 to 1. So we'll say, oops, u of 4 is equal to the square root of 4, which will be 2, and u of 1 is equal to the square root of 1, which will be 1. So now we have 1 to 2 times e to the u, and I'm going to leave the square root of x in here, and then I'm going to plug in du for dx, and we get that it's du times 2 square roots of x, so that these cancel out, and I get 2 times the integral from 2 to 1 of e to the u du. And that's it for this question. So it's not too difficult. It looks like we found the wrong limits of substitution here, and we didn't take the limits of substitution here. So be careful when you're solving these problems. As always, if you have any questions, please don't hesitate to contact me so we can get that sorted out. Thank you, and that will be it for today.